Hi everybody, I'm going to be showing you how to do surface tension study. This is actually for my science fair project, so let's get started. First we're going to do the milk.
So what liquids are you doing today?
I'm doing milk, lemonade, water, and oil.
Mm-hmm. So tell me what you're doing as you do it.
Well, I'm pouring the milk right now, and let's see this. Yeah, that's enough milk. That's enough milk for you, cup. And we're going to take a paper towel, and we're going to rip some of it.
Let's do each liquid first, and then the paper towels, I think, because you don't want the paper towel to get too soaked.
Yeah, you're right. Okay, now the lemonade. And we're going to have enough for us to drink after this.
Yeah, there will be some left over of milk and lemonade and water, and probably oil, too, if you want to drink that.
No. That would be a very bad idea. It is not healthy for you at all.
It's not very healthy. You do need some fatty acids to be healthy.
And now for the most dangerous one of all, the oil.
God, please don't get it on the carpet.
I'm not.
Okay.
Mom.
So do you think it's important to pour the same amount of liquid in each bowl, or does you think it matters?
I think it matters because if we don't have the same amount of liquid, we won't have the same amount of surface tension.
Ooh, you think so?
Yes.
So that's your hypothesis?
Yes. If we don't have the same amount of liquid, we won't have the same amount of surface tension.
But what is surface tension? What is surface tension?
Okay. If you can see me, do it with your hands.
Okay.
This is how many surface tension there are. If there are a lot of surface tension, then it will break.
Mm-hmm.
If there's a little bit surface tension and there's a little surface tension, then it will not break.
Huh. I thought it was the other way around. I thought when you said a lot of surface tension, I was thinking there'd be more tense, a lot of tension, so it would hold more.
No. Because I have no idea.
Right. So love it. So think about when we talked about what surface tension is. We talked about what it was made of. Do you remember how we said surface tension was made? You got the bonds right. I hear what you're doing with your hands. I remember that example.
Can we just move?
I need to make sure you understand what you're testing.
Well, so I know it feels like it's the other way around, but really, surface tension needs to be strong.
Yes.
And they stick on.
Yes.
Basically, picture you lifting a heavy weight,
Mm-hmm.
and picture surface tension sticking together. That is like you lifting different pound weights. Little is, you can lift a lot.
Yeah, I get that. Here's what I'm saying. What causes surface tension? We talked about it. We used some Smarties. We used some Starbursts.
Every time I got one right, I had a Starburst of Smart.
But that isn't what we're talking about. Not about how much candy we ate during the demonstration. It was how surface tension comes to be.
Well.
So remember what we did with the Smarties. We put them in rows, and we talked about what between each of those.
Oh, let me, do I have something to demonstrate on?
No, answer my question, my darling. We talked about what holds them together. What's that called?
I really don't know.
A bond?
A bond, yeah.
Okay, so what's different about the molecules on the surface as opposed to those below the water?
Well,
The water's surface.
the molecules on the top have less, so they are stronger.
Less what?
Less other molecules.
So they don't have to have so many,
Surface tension.
so many bonds.
So many bonds. But down below and in the middle have a lot.
Uh-huh.
So they have a lot of bonds.
So are the bonds, when you have a lot of bonds with different molecules around you, are those bonds stronger or weaker than the bonds when you have fewer molecules to bond with?
Well, the fewer molecules are stronger.
Because they don't have to distribute their strength in many places, right?
Exactly.
Okay, you're just going to agree with me now.
and the ones with the most are little and they are weak.
Okay. That's good. Okay, so let's move on to the experiment.
Okay.
Tell us what we're going to do.
So, here I poured the milk, the lemonade, the water, and the oil.
Very good.
Without making a mess.
Without making a mess. That right there is a triumph.
We're going to take this paper towel and I'm going to cut. So let me get my scissors for it.
Okay.
Just keep staring at the project.
I will just stay right here.
Thank you. I'm going to get my scissors. I don't want it to be messy.
Okay.
Then, you cut a little piece of the paper towel.
So do you want to cover the whole top of the cup, or do you want to do just a little piece?
Just a little piece.
Oh, I didn't know that.
Because if you cover the whole top, it's like making milk spoil. So basically, you have to cut it.
Like what?
Making milk spoil.
Is it? Okay.
So you have to make sure it is smaller than.
All right, so tell me what you're doing at every step.
Okay.
So now why are you placing the paper towel on the milk?
First, because if you do it the other way, it will only cover it and make it heavier than it really is.
What does the paper towel do?
Well, let me demonstrate.
What is the cat doing?
Don't worry about the cat. So
I am worried about the cat.
when you place it on, you place
Schrodinger's cat.
on. You place this on, and then you slightly do it down. And if it floats, it floats. But if it doesn't float, then it's heavier. So basically, the surface tension breaks, or the surface tension holds on.
Okay.
So let's try it out.
All right, let's go.
So let's do that.
Okay, wait. Tell me what you're doing. You put the paper towel in, and then what?
Then the paper clip. Then slightly push it down.
So you're pushing the paper towel down?
Yes.
Now, why are you doing that?
Oh.
Wait a minute.
Oh.
Are we sure? Here's my question. Are we sure that it didn't stick to the paper towel?
It did stick. Oh my gosh.
Maybe we try it with just the paper clip. I don't know. You can put on the it's right there.
No, it is not going to be the experiment.
Will you just humor me for 1 second and just try it? I'm just curious.
Fine.
Oh, that didn't work very well, did it?
Yeah, it didn't work as I expected. So I'm going to try another paper clip and see if I'm right, if it doesn't work.
So you're going to try it again on the milk?
Yeah.
Okay.
Because you have to double check.
Yeah.
Always make sure you are right before you do it.
Before you give up?
Yeah. Before you're done, I meant.
Okay.
Like on test, you have to check it first before you are done. So first you place it in gently. After that you place then you push down the sides. And I do not feel any paper towel on it, only at the bottom.
So, what do we think about the surface tension of milk? You think is it strong or is it weak?
It is strong because the paper clip is floating.
But there's something different about those paper clips. Look at them together. Take the paper clip and put it beside the white one.
Oh.
What do I notice? What do we see that's different besides the color about the paper clips?
They're different shapes?
They are different shapes. Do you think that has an impact on the surface tension?
I think that does. So, since this one is basically a change of different shape, then it is wrong. Let's see what happens when we change the shape of one.
Ooh, I like the way you think.
I'll change it like that.
Okay.
Let's try that.
All right.
Okay.
So far, we have the flat yellow paper clip floated on the surface tension. And the bent white paper clip did not float.
Well, we don't know yet.
No, it was a little bit bent out already.
Yes.
Okay. So that didn't work. So now you're bending it more. And what is the cat doing?
Don't worry about the cat.
I am super worried about the cat.
Don't worry about it.
The cat is worrying me.
Okay, so let's see if this works.
Okay.
Maybe milk has another surface tension. So then You place the funny looking shape on it, and then... Oh!
Huh.
So this time it didn't float. So changing the shape does matter.
Okay. Well, that is milk then, isn't it? So
Yes.
now what are we moving on to?
Lemonade.
All right. Do you want to dry your hands off the milk first so you don't...
It's fine, actually.
It's really not fine. I'm just shaking the milk everywhere, aren't you? That's really not acceptable.
I'll get an extra paper towel.
Yeah. No me gusta.
There.
Okay.
Okay. Now let's start to. Now I'm just gonna do a smart idea and cut the whole thing out, like the whole line. So every time we can just.
So I have a question for you while we're going to the next liquid. I noticed something about these. Do you know what density is? It's how thick something is.
Yes.
Do you think that density has something to do with it or just surface tension?
Surface tension.
Really? Interesting. I don't have an answer, I'm just asking.
Don't look at me. I'm kidding. Okay, so that's enough. Alright.
So we're done with the milk, now we're moving on to the lemonade.
So I'm gonna pick two.
I'm gonna move my hiney over here.
Okay. So first,
The backpack.
sacred paper towel.
Is it sacred?
I'm kidding.
Wait, look at the... Oh, you've got two different... Okay. Go for it.
First you place that in. Then you place that in. And let's get this.
You can see it better on lemonade because it's not all white.
Yes.
Interesting.
And it is floating.
That's cool. So what do we think about that?
I think it floats, but when you touch it or place it down, it doesn't float.
But your finger is breaking the surface tension too,
Yes.
right?
Yes.
I should have asked you. What are you doing that's different?
Yeah.
Blurg. No Socratic questioning
So
from
now
mommy.
we're going to water. And I know this one's going to float.
Did you want to do it twice in the lemonade like you did with the milk?
I think that is a great idea.
Okay.
And this
Want to
one,
use the same paper clip or a different paper clip?
a different paper clip that has changed shape.
Oh, okay.
So we can test it out. You never know. These might have different surface tension.
'Tis true.
'Tis a law.
It's already falling down in there,
So,
isn't it?
Yeah.
So I guess we know the answer to that.
Boom.
Boom. And now we're moving to...
The milk. I'm kidding. Just the water.
This is just plain old water.
Fresh from a cow.
Yeah, very weird.
Yeah. What if streams held milk and cows held water?
I think the landscape might smell very different.
Yes. Very different. So if a waterfall was near you, would say, "There's a cow nearby." And if you smelled some water near you, you said, "There's a stream nearby." Okay, let's do this. I know this is gonna work. Boom. Oh wait.
And it floats, right?
Yep. But what if I touch it?
I don't know what happens.
Oh. Oh.
But why does it do that?
Because the surface tensions break.
Uh-huh.
Let's test it another time with the shape removed. This time I'm gonna use the same one.
Okay. I'm a terrible camera person. Oh, it just floated down on its own.
Yeah.
I guess we know what happened there. And now we move on to the thing I was most afraid of you working with.
Oil. Yeah, because I'm gonna get it on my hands.
Yeah, well, we got lots. Boom, paper towel roll.
Let's move the oil out of the way.
Okay.
So the last one, we're going to test 4 times.
4 times.
Do you know why?
I do not.
Because every one of these had different surface tensions if it floated or not floated.
Uh-huh.
So this time we have to test it 4 times to make sure we are right. This is a different kind of surface tension.
It is?
Yes, and I just know it because it is sticky.
What's sticky?
This.
The oil is sticky?
Well, I don't really. Let me put my finger in. Basically, you can't feel it. You can feel water, but you can't feel it. It's sticky.
Oh.
It's sticky. 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 It's sti this and this, but you cannot feel oil. I mean, you can try.
You want to get a paper towel for that finger of yours? Let me help you with that.
I already have my own.
I'm just going to give you another one just in case.
Yeah, but still, you cannot feel it, so it might have different surface tensions.
So you think it might be surface tension that makes you not feel it, or you think it might be something else?
Might be something else.
What do you think it might be?
I don't know.
Okay.
It
Good.
might be surface tension.
I don't know. In Emerson, in science, I don't know is a perfectly acceptable answer.
And then, well, let's try. It is sinking slowly.
It's sinking. Oh, it is sinking slowly, but not fast.
Yes.
But those all sank fast. What do you think that signifies? What do you think that means?
I have no idea.
Okay.
And when it comes out, it is clear.
Yeah, that's oil for you. It's kind of crazy. All right, you gonna try it again?
Yeah, I'm gonna try. That's weird. Like how it comes out clear.
Yeah. Will you please not flick your fingers everywhere? Will you pretty please not do that? I do not need oil all over the place.
Okay. Right there. Then.
So it doesn't float. It automatically starts
Sinking, but slowly.
but slowly. So what do you think? Do you think that has to do with surface tension or density or something else?
I really don't know.
That's a fair answer. I don't know is a perfectly good answer in science.
Because you're discovering new things.
Mm-hmm.
Now I'm going to change the shape.
Okay. See if that makes a difference?
Yep.
Okay.
And then we're going to test it one more time with the change shape.
Okay.
Boop. And then boop.
Doesn't matter, does it? No
Let's test
change.
it. Let's test it one more time.
Okay.
But I have no idea why they come out clear.
I would say, I don't know. I really don't know.
Let's see. Yeah, this one just automatically starts. Yeah.
Okay.
So,
what do we think?
I think that all of these float except oil.
And I would have thought because oil is thicker than everything else on the table, I would have thought that the paper clips would have floated, but I was wrong. So the density, the thickness, maybe it doesn't have anything to do with how well it floats on the surface. Maybe it is all surface tension. What do you think?
I think it's both.
Oh, well, snap.
Because this is thick.
Mm-hmm.
Not that thick. Not that thick. Thick. That one,
Is it thick?
It's a little bit thick.
A little bit thick. So a little bit
Tiny lot.
So
Because that
very dense, not very dense, tiny bit dense, more dense, but not as much as the oil.
Yes.
And then
Because that one started to sink a little bit, and then started to float back.
wait, are you saying stink or sink?
Sink.
Oh, I thought you said stink. I was like, I don't smell anything. But I also have a cold, so.
Yeah. So basically, yeah.
So what do we think?
I think all of these are great, and but look, it swishes back. So.
Please don't do that. Please put the oil
Swish,
down.
swish.
I am begging you to please put the oil down. Oh my god.
Swish, swish.
Stop. Seriously, Emmy, come on, man.
How about I swish, swish, swish?
How about I swish your face?
Swish, swish.
Come on, baby.
Swish, swish, swish.
Emmy.
I'm gonna pour all these out.
Well, let's talk about what we've learned today. Put them down. Let's talk about what we've learned. What have you learned?
You ask the question.
Ask me more questions.
Okay. Just say a question and I'll answer it.
All right. What is your name?
Emerson.
All right. So how did the shape of the paper clips affect how well they floated?
Well, when this happened, air could not flow through, so the surface tension. I meant when I placed it down with the paper towel, the surface tension braked because it was not as it seemed, and it was not in its original form. So it was basically, I don't know.
So the original form seems to lie how on the water? When I lay it down, is it laying down? Is it standing up? Is it poking down? It
is laying like that.
The original form of the paper clip.
It is floating.
But it's flat, right?
Yes. And this one is like
Poking
that.
down.
Yeah, poking down.
So what do you think that one does with the shape? The shape does what to the surface tension? It breaks through it. Do not lick the paper clips. Are you kidding me? Stop. There's a whole bottle of lemonade here left.
Okay.
Here, drink that. Gravy.
Look at you, take a picture of her. Come on. That is our cat. Just so you know. Do not go near her. She is a devil.
She's not the devil. We've got to reorganize this living room. Okay, anyway. So what conclusions are we drawing besides don't laugh and drink lemonade? No, she's biting her own foot. She's like, no, foot, I will get you.
Sour. And now she is rolling over and licking herself.
Yeah, well.
What?
She look at her face.
Her tongue is like this.
Can I zoom in on that?
Wait, her tongue is like
I
this.
see it. Yeah. Her tongue is sticking out.
Why is her tongue sticking out?
Because she was licking herself.
Blech. I'm trying to touch her tongue.
Okay.
That's kind of funny.
Okay, well that was funny. Cat break. Yeah. Alright, so let's wrap it up. No, that's stimulating, Emerson.
Boring work.
That was boring work? You seemed pretty excited about how the experiment worked out.
No, I mean like I am at work.
Okay, I'm asking you to wrap up the experiment, my darling.
Oh. Well, do you have some wrapping paper? Okay. Well, I have learned a lot today that I didn't know about stuff. I didn't know that paper clips can float on 3 liquids except one.
Mm-hmm. Which 3 were the ones that floated?
The 3 ones that floated is the milk, the lemonade,
Dear Lord.
the water, and, but not the oil. So, yeah, I'm going to touch my fingers in all of these. So, they all floated except...
Did I mention you have to drink all of those now?
Oh my god. Okay.
Even the oil? Just kidding. Come on, finish what you're talking about.
But, except the oil didn't. And also the oil is warm. Very warm.
Well, it's been over the stove and we've been cooking. Please stop playing in the oil, my darling. Please. Okay. Here's a paper towel for you.
Okay, but still. So I've learned a lot today that I didn't know.
Mm-hmm.
I hope I get an A on the science project. So